Okay, so imagine that you're given the following chemical reaction and you're asked to balance it. Well, for it to be balanced, it has to have equal numbers of each element in the reactants and the products. And we'll go through how to do this. Ultimately, the only thing you can change is the coefficient that you put in front of the element, or in front of the molecule or the compound, in front of the formula. You can't change the subscripts. Those are determined by either the bonding inside the molecule, or if it's an ionic compound, by the relative charges of the constituent ions. So let's count these up as they are right now. Right now there aren't any coefficients in front of, well, apparently there's extra spaces for no reason. There's no coefficients in front of any of these formulas. So if I look at hydrogen, I have 3 hydrogens from the phosphate, right? Or from the phosphoric acid. How many hydrogens do I have for magnesium hydroxide? The subscript here is, there's no subscript there, right? So that's like an implied 1 for this hydroxide ion, and then there's 2 hydroxide ions. That's what the parentheses mean around the OH. So that 3 contributes 3 hydrogens to the count, and then I have 2 times 1 for the magnesium hydroxide, so that ends up being 5, right? How many phosphorus atoms, or how many phosphoruses are in the reactants here? 1? Okay, because there's no subscript after it, so that means there's 1. Okay. Oxygens. How many oxygens come from the phosphate? 4, right? Okay. So how many come from the hydroxide? Right. So that's 6 total. Magnesiums, how many do I have? Just 1, right? Okay, so if I look at the following products, how many hydrogens do I have in the products? Just 2, right? Just from the hydrogen, from the oxygen. So how many phosphoruses do I have in the products? Who votes for 1?
What was the question?
How many phosphoruses are in the products? Who votes for 1? All right, there's 2. 2 times 1, so there's 2. And then how many oxygens are in the...
8.
Yeah, exactly. So there's 4 per phosphate ion, and then there's 2 of those. That's what the parentheses means. There's 8 total. And then for magnesium, how many are there? 3, exactly. Okay. So I look at these different totals for the elements, and I can see that none of these are balanced at all. Like, none of these elements are balanced. So the question is, which of these coefficients am I going to change first? And I always try to change the thing that would cause the most drama, the most problems, and then try to fix everything else that's going to cause the least problems if I try to adjust them, right? It's kind of like packing, like the back of your car or something. You put the big thing in first, and then you kind of like fit all the other crap around it, right? Like, you don't put the little stuff in first, and then hope that like the big stuff kind of, right? Okay. Or like if you're married, you kind of make your plans with your wife, and then everything else kind of goes around that, right? I mean, like the big decision makers get done first, right? So if I'm looking at this stuff, I'm probably not going to choose H2O to try to balance it first because it only has 2 elements in it. I think what I'm going to do is one of these 2. Do you guys have a preference? This phosphate or this phosphoric acid or this magnesium hydroxide? Okay, so I'm going to do the first one first. So I need there to be 2 phosphoruses here, so I'm going to put a 2 in front of it and see what happens. So I've just changed the number of hydrogens and the number of phosphoruses and the number of oxygens. That's a lot of things to have changed. That's pretty good. So the hydrogens have changed. Instead of just 3, it's 2 times 3. So 2 times 3 is 6, plus 2 times 1, that's 2. 6 plus 2 is 8. Did I get that right? There's 6 hydrogens from here and 2 from here, so that's 8. There's now 2 phosphoruses. And the oxygens have changed too. I've increased the number of oxygens. Instead of just being 4 times 1, it's 4 times 2. So that's 6. Nope, that is 10, right? Am I nuts? 8 from these guys and 2 from these guys, so that's 10. Magnesium stays the same. I haven't changed the number of magnesiums. So now the phosphoruses are balanced. A lot of other things are not balanced. What should I try changing next? Should I try changing this one next? Or should I try changing this one next? Which one do I need to increase to make things balanced? Like, are there fewer magnesiums on the reactant side or on the product side right now? Right, there's only one on the reactant, so I'm going to try to increase it. If I multiply this by 3, I'll end up having 3 magnesiums in the reactant side. So that'll balance the magnesiums. But now I have to change the hydrogen and oxygen again. So that 4 times 2 comes from the phosphoric acid. This 2 times 1 used to come from here, but I have to change it. It's now 3 times 2 times 1. So 3 of these, each of them has 2 hydroxides, and then each hydroxide has 1 hydrogen. So that's where I get 3 times 2 times 1. So that's 6 plus 8, that's 14. And I also need to change the number of hydrogens because now it's 3 times 2 times 1. So that's 2 times 3 from over here, so that's 6 from these guys, and then 3 times 2 times 1, so that's 6 from these guys as well, so there's 12 total. Okay, so let's take a look. Are the magnesiums balanced now? Yes. Are the phosphoruses balanced now? Yes. Are the oxygens balanced now? Definitely not. Okay. So I'd prefer not to mess with this if I can, because that would unbalance my magnesium and unbalance my phosphorus. So my hope is that somehow by manipulating this water molecule, this H2O, I'll be able to balance everything up. So if I have 12 H's in the reactants, and I want to get 12 H's from the water, how many waters do I need? 6, right, because I want to get 12 total, so that's 6 times 2. If I have 6 waters, that means that I now have 6 times 1 oxygens from the water. So that's going to be, I apparently forgot it last time when we did this originally. 6 times 1 oxygens from the water and 4 times 2, so I think that's 14. 6 times 1 from the water and 4 from each phosphate ion, and there's 2 of them, so that means 8. So 6 plus 8 gives me 14. So this is balanced because all of the elements here match up with all the elements in the products. If I count them out, if I chop up all of the elements and then add them up by just what the elements are, they're the same amount in the reactants as in the products. So I haven't cheated at all. I haven't materialized matter out of nothing. I haven't created elements that weren't there. Does that make sense? It's a long and involved process, but you get very good at it by the end of the class.